Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm answering question number 3 from the June 2008 Pure Mathematics P1 Cambridge 9709 syllabus. This is a question on binomial expansion, and it's actually question number 3 as well from my P1 end of topic worksheet from my Cambridge collection of P1, and it's the whole worksheet is about binomial expansion. So here for part 1 says find the first 3 terms in the expansion in ascending powers of x, of 2 plus x squared raised to the power of 5. Okay, so when we want to expand something like this, we can use the NCR method in these cases when you have a positive integer, and basically you set it up with your I put like 3 brackets here. One for the binomial coefficient, the other one for the first term, so I'll put 2 here, and the other one for the next term, which is x squared. So whatever's here, including the sign, so if this is negative, I'd put negative here. And the power is 5 of the whole bracket. So there's going to be a 5 here, and we always start with 5, 0. Now I want ascending powers of x. So I want this one to start with the lowest number, which will be 0, and therefore this will have to start with 5 because these 2 numbers always add up to this number here. So this will be 0, this is 5, 5, 0. Okay, this is all derived from looking at the patterns that we see when we expand brackets, these binomial brackets. So the second term will be given by 5, 1, that number, top number stays the same, it's the same as this power. This one increases by 1, and in these cases the powers keep changing, like this one decreases by 1, this one increases by 1, such that these will always add up to that 5 up there. And we have one more term because there's first 3 terms. That's the first term, second term, third term is going to be 5, 2, and we have here 2 to the power of 3 because that's going to be going down by 1, and this is x squared to the power of 2, it's going up. Okay, so those would give us the first 3 terms in ascending powers of x. So we're going to work out what this is now. Anything like NC0 will always be 1. Okay, so it doesn't matter what number there is, it's going to be 1. Then 2 to the power of 5 is 32. And x squared to the power of 0 is 1. So the first term is 32. The second term, 5C1, well, that's going to be 5. Right? NC1 will always be n. Times 2 to the power of 4, which is 16, times x squared to the power of 1, which is x squared. So 16 times 5 is 80, so you have 80 x squared. Okay, then for the next term, 5c2, well, I know that's 10, but in case you don't know, that's 5c2. That's how you find the value of that coefficient there. That's going to give us 10. So you have 10 times, you have 2 cubed, which is 8, times x squared squared, so you multiply the powers, that gives you x to the power 4, so that's another 80 then, so about 80 times x to the power 4. So we have completed part 1. We found the first 3 terms in the expansion, so we can say 2 plus x squared raised to the power 5 is going to give us 32 plus 80x squared plus 80x to the power 4. So there's the answer, the first 3 terms in ascending powers of x of this bracket. So that's the answer to 3 part 1. Now for 3 part 2, it says hence find the coefficient of x to the power 4 in the expansion of 1 plus x squared squared times 2 plus x squared to the power 5. Now notice when it says hence it always means using what we've done before, and we notice that this is the same thing as what we have already expanded. Okay, so what I can do here is I can say this is going to be the same thing as 1 plus x squared squared times, and we got this, 32 plus 80x to the power of 2 plus 80x to the power of 4. Okay, now the other terms of this, you're going to have something x to the power of 6, then something x to the power of 8, as you can see from the pattern. We're not concerned with those other powers because we want to find the coefficient of x to the power of 4, and when we get x to the power of 6 here or x to the power of 8 here, of course those coefficients, those powers will be too high for us. We don't want those ones. We only want the coefficient of x to the power of 4. So what we're going to think of is when we multiply these two brackets, we have to find the one which, or the terms which are x to the power 4 terms. Before I can do that, let me just expand this. Now this is a simple type of expansion because it's just squared. So this is like using our pattern of squaring brackets. Square the first term, multiply these together and double the answer. That's going to be 1 plus 2x squared, and then square the last term. That will be x to the power 4, and we got our 32 plus 80x squared plus 80x to the power 4. So now we got to think about what terms multiply together to give us the x to the power 4 coefficient. So what we can do is, you can see here, if I multiply 1 by 80x to the power 4, I'm going to get something in the, with x to the power 4. So I have 80x to the power 4, and then if let me just change the color. If I multiply this with the x squared term, x squared times x squared is going to give us x to the power 4. So I can say that plus 2 times 80, 160, x to the power 4. That will be another x to the power 4 term. And then we can see, let me choose another color. When I multiply this by 32, I'll also get x to the power 4 term. All right, so that will also give me x to the power 4 term. So I've got 32 x to the power 4. Those will be all the x to the power 4 terms. All right, so that I don't have to go and expand the whole thing, do this 1 times this and 1 times that and 1 times that and so on, and then just pick out the x to the power 4 terms. I can think in advance. When I multiply constant by x to the power 4, that will give me x to the power 4. X squared times x squared, x to the power 4. X to the power 4 times constant, x to the power 4. So those together will give us our x to the power 4 terms. That's 240 plus 32, 272 x to the power of 4. And it says find the coefficient of x to the power 4. So please be careful. You can say that the coefficient is 272. Don't write it with the x to the power 4. Okay, don't write it with x to the power 4. We just want to write down the coefficient. So make sure you do that very carefully. You don't want them to give you, or you don't want to give them any excuses to lose, take marks off you. All right, so be very careful. It says coefficient. If it says find the term in x to the power 4, then this would be your x to the power 4 term. It says coefficient, it's just a number that's multiplying x to the power 4. It's very important for you to understand that. So that completes question number 3 from this paper, June 2008, and question number 3 of my worksheet on number 8, binomial expansion. This was upon the request of one of my students. Other questions from this particular paper will be found in the playlist, which will appear at the top right of this screen at the end of the video. Other questions from the topic of, or from this end of topic worksheet, you will find in the playlist over here. If you find that a question has not been answered that you want, you can just send me a request, and I will see if it's worthy of a video, and I will make the video if necessary. And then you can watch other questions dealing with binomial expansion in general from my P1 material of Cambridge over here. And I'll also put here a link to my Edexcel binomial expansion work. That's in P2 in Edexcel. I'll put that over there so you can refer to they're very similar type of questions, and there's a lot more there right now, so that will help you maybe look up some more type of questions. So that concludes this video. Thank you for watching, and see you soon.